right, so now we have with us the wonderful astroeducator Michelle NIchols, and she's going to be talking about one of my favorite planets, which I still think is a planet, Pluto. Hi, Michelle.
Hello, and yes, you most certainly can think of Pluto as a planet because there is no one single rule on planet Earth that says one group of people is in charge of calling something a planet or not. So it's totally fine. So, yeah, why don't we get started? I was really glad that the library picked this one because it's a topic that got some airplay, so to speak, around 2015, 2016, 2017, and then kind of dropped off the radar a little bit. But Pluto is an extraordinarily interesting place, and I love talking about it. It is one of my favorite worlds in the solar system. Yes, I have favorite worlds in the solar system, so I'm that kind of a geek. But we're going to talk a bit about the history of the discovery of Pluto and the person who was most instrumental in that. Going to talk a bit about what we knew about Pluto prior to the New Horizons spacecraft flying past Pluto about 6 years ago. And then what did we learn from that mission in general? And the short version of that is we learned a lot. And Pluto was not really much at all like what we thought it was going to be. So we thought it was going to be a frozen rock ball, and parts of it are a frozen rock ball, but not all of it. So why don't we get started? I'm going to share my screen, and I put in the chat. I'm apologizing in advance to anyone using the captions and to what Zoom's captioning might do to some astronomy specific content and words. So just apologies in advance if it turns out to be something strange. So here we go. All right, give my computer a couple seconds to connect. There we go. All right. So the person most instrumental to the discovery of Pluto, his name was Clyde Tombow. He was born into a farm family in Streator, Illinois. So yes, he is an Illinoisan. We will claim him. He was born in 1904. And the picture that you see here is one of the telescopes he built himself. Parts of the telescope were built from the crankshaft of a 1910 Buick and a cream separator. I would imagine a cream separator would be something you pretty readily find on a farm, especially that time period. He later sent drawings that he made of Jupiter and Mars to the Lowell Observatory in Flagstaff, Arizona. He was looking for some comments and suggestions on his work. Instead, the observatory staff offered him a job. Clyde accepted the job, and he joined the search for Planet X, so named for Percival Lowell and the planet that he thought existed beyond Neptune. Now, Clyde Tombaugh's job was to photograph one small piece of the night sky at a time, and then go back and photograph that same piece of the sky a few days later. He then had to carefully compare the two photos, and if the two photos were lined up exactly right, if anything moved from one photo to the next, you would see that part of the image jump back and forth as you flip between the two photos. He photographed 65% of the sky, and he spent literally thousands of hours examining these photographs. It was 10 months of really hard work. And in a telescope dome, telescope domes, if you don't know, they're not heated, they're not cooled, they're just at the ambient air temperature. So I'm sure some of those nights were pretty uncomfortable. Now this is a photo of the machine that did the blinking between the two images. It's called a blink comparator. And you literally put one image on one side and one image on the other, and it will blink, go back and forth between the two, and your eye will pick out whatever moves. And this is the blink comparator right here. And that is the one that would eventually show Clyde Tombaugh an interesting result. And so here are the two images, and these are the two discovery images of the planet Pluto. So notice the dates: January 23rd of 1930, January 29th, 1930. So he took these photos about a week apart. And so between these two, if you line them up exactly, you would notice that thankfully there's arrows here, or else you'd never be able to pick these out. But this object would jump from one photo and it would jump to a different position in the other photo. And he did discover other things while he was doing this. It wasn't just all of a sudden, bam, there's Pluto. He had discovered some comets or I believe some comets, definitely asteroids. And so it took a while before he found something that jumped the right distance in the photo, because that indicated that it was a far enough distance away that it was likely out past Neptune. Now, Clyde Tombow worked at the observatory there from 1929 to 1945. After his discovery of Pluto, he earned bachelor's and master's degrees in astronomy from the University of Kansas. And during World War II, he taught naval personnel celestial navigation at Northern Arizona University. Side note, celestial navigation was taught all over the country at various locations. Northwestern University was involved in teaching celestial navigation to naval aviators. And at one point, the Adler Planetarium was also used briefly for some classes for folks who would need celestial navigation. And so it was an effort that wasn't just centered on one part of the country. It happened everywhere. He worked at White Sands Missile Range in the early 1950s. He taught astronomy at New Mexico State University. And there is an asteroid named after him. It was discovered in 1931. He discovered hundreds of asteroids, and mostly as a byproduct of his search for Pluto. He named some of them after his wife, his children, and his grandchildren. Side note again, if you discover a comet, it is named for you. If you discover an asteroid, you get to name it, but you don't get to name it after yourself. So that's basically what's come down over the centuries. So I may have misspoken. I don't think he discovered a comet, but he definitely discovered a lot of asteroids. So at some point he's probably thinking, man, I got a lot of these things to name, so I'm just going to start naming them after people. So anyway, he passed away in 1997 at the age of 90. Now here is a picture of Pluto, and where the arrows are indicating is stars of different brightnesses. So the numbers that you see, the lower the number, the brighter the star. For comparison, the dimmest star that you can see with your own eyes in a dark, clear, perfectly dark and clear sky is about magnitude 6. This is magnitude 9.2, so that would definitely be a star you would need a telescope to see, or small or decent pair of binoculars. And this is a little dimmer, 11.7, 12.7, 13.5, 13.8. And if you compare the brightness of Pluto, it is pretty dim. If you're wondering why we didn't discover it sooner, it's because it is a dim little thing. And also, it's just really not that big, as we found out later. Now, Percival Lowell thought that Pluto, and others thought that Pluto was bigger than it turned out to be. More about that in just a little bit. Pluto has a really interesting orbit. It kind of dives into the interior of part of Neptune's orbit. Now, Neptune and Pluto will never collide, at least not anytime as far as we can tell. But the angle of Pluto's orbit is angled quite a bit more than the rest of the planets in the solar system. And there are other objects that have orbits that are angled even more than Pluto's is, and some definitely less. But the rest of the planets orbit essentially in a plane. Imagine the solar system as a flat sheet of paper. Pluto's orbit would be angled to that piece of paper. As our telescopes got better, we realized, Pluto's really not that big. And in the late 70s, there was an indication that Pluto had a companion. And so you can kind of see in this reverse image that you can see the dot for Pluto, and it kind of looks like there's something off the edge. But later on, you don't really see it. And maybe there's a suggestion that it might be here. That was at least an indication that Pluto had a decently sized moon. And when we started getting better pictures of Pluto and its moon, we actually could separate them. And there were other moons there too, as we found out in the last few decades. Pluto has a total of 5 moons. Its largest is Karen. Karen is about half the size of Pluto. I'll give you a sense of how Pluto compares to the Earth in just a little bit. But Karen is about half the size of Pluto, and the others are definitely a lot smaller. So I'll give you a size indication near the end about the other 4 compared to the size of Pluto and Karen. Anyway, but notice you're not really seeing any detail here with Pluto. The best Hubble Space Telescope image we ever had of Pluto was this set right here. And this was taken prior to when New Horizons flew past in 2015. So I'll get to that in just a second. But just to give you a sense of the size of Pluto. It's tiny. So you could fit Pluto in the borders of the United States and have more than half left over of the United States. And so then its moon Karen is about half its size. And so this hopefully gives you a better sense. This is a tiny world. It is when it was considered by the International Astronomical Union to be a planet, it was the smallest planet. And so it was something that basically by the size, we kind of went, well, this thing's just going to be just frozen rock ball, something just left over from, it's going to be similar to maybe how it was billions of years ago when the solar system formed. Oh, maybe we'll see what the conditions were like in the early solar system by studying the surface of Pluto. So sent the New Horizons spacecraft past, and it took pictures along the way. The spacecraft was going too fast to go into orbit around Pluto. That was never the plan. But as it flew past for several months before and several months after, took a lot of pictures. And the picture that I showed on my title slide is a true color picture of Pluto. And even with an untrained eye, if you've never seen this picture before, if you're not sure what to look for terrain, look for stuff that looks different from other stuff. If I say that, then probably your eye might go to this dark area here and maybe to this lighter area here. What's interesting is when you take a look at some of these Hubble pictures, this area right here, we realized was this area right here, because I can remember when they were releasing those Hubble photos that people were speculating as to what that brighter area was. And so it turns out it's ice. And but it's not just ice sitting there on the surface. The surface of Pluto has different ages, meaning something has been causing the surface in certain spots to resurface itself. There is activity happening here. The planet isn't just orbiting the sun and sitting out there in the frozen depths of the solar system. There is stuff going on. I'll describe what's going on in just a little bit, but it is definitely quite a bit different from what we initially expected. Now, the next image is if you take the same picture and you assign different colors to the different types of surfaces. So this is a false color image. Think of it as paint by number, where they said this part of the surface, this type of terrain, we'll paint it this color. And this other type of terrain, they'll paint it this color. So these cratered areas over here, these cratered areas, so you can see craters right there, right? So craters are just when something from space smashes into something and makes a hole. These cratered areas, they estimate based on the number of craters that they can see, that surface is probably about 4 billion years old. And that essentially takes us back to not too long after Pluto formed, about 4.5 billion years ago. This area right here is probably only about 1 billion years old. Again, I'll get to what's going on in that region in just a bit, but let's take a closer up look. You can see, take a look. Can you see craters here? I can see a lot of them. Do you see any here? No craters. That is really interesting because you would expect if there's just ice sitting out on the surface of someplace, eventually something is gonna run into it and make a crater. So unless that surface is not that old and it just that ice hasn't been sitting there all that long. But this bright expanse right here is got a lot of different kinds of ices. You can freeze different materials and get different kinds of ice. Ice doesn't just mean the stuff that's in your freezer at home, water ice. You can have nitrogen ice. You can have carbon monoxide ice. You can have methane ice. Basically, if you get something down cold enough, it'll eventually, if it's cold enough, it'll eventually turn into an ice. But this area right here is made of all of those ices, nitrogen, carbon monoxide, and methane. This area right here is almost perfectly flat. It is ringed by mountains. These are ice mountains. These look like rock, but they're actually ice. The ice mountains are 2 to 3 miles high. The area of that you can see here is pretty big, but again, down to a few hundred feet. We've taken close-up images of this area. Can't find any craters. There may be smaller ones, but there aren't bigger ones. And again, you would expect if something's just sitting out there and nothing's happening to it, eventually it's going to get hit by something. Pluto has not been selectively hit to avoid that area. So it means that that area just isn't that old. It may be an impact basin. This may be an area that got hit by something from space that was somewhere in the neighborhood of 60 to 125 miles wide. I'll say that again. This thing got hit by something that was 60 to 125 miles wide, creating a crater that big. But it's and that somehow that created some heat that caused this ice to move and to flow and to bubble. And I'll show you the bubbles in just a bit. But this is the largest glacier beyond those that are on Earth. We can see what looks like the ice flowing. You can kind of tell where some of these little swirls, thankfully they put some arrows here so you can kind of see it. You can see where the ice seems to be flowing from here out into some of those more rocky areas. So we think the ice is actually flowing. It would be great to have a spacecraft here that can see Pluto over time. The spacecraft wasn't there long enough to actually see the ice moving, but this is just a snapshot. So that's what we think is going on here. But what's also really interesting is this glacier, this whole thing is made of nitrogen, and no nitrogen glacier has been seen anywhere else in the solar system. This is unique to Pluto as far as we can tell. Here are some of the bubbles. All right, you can kind of see them right here. What's going on here is the material down below is a little warmer. The material up above is cooler. The material down below that's warmer bubbles upward and bubbles up in the middle of one of these little cells and then flows outward and down. The best way I can relate that is it's like a lava lamp. You have a heat source there at the bottom. You got the bubbly material. It warms up, it bubbles upward, it cools off slightly and falls back downward. And that's what's going on with this ice, we think, is each of these little cells right here is bubbling up ice, warmer down below, bubbled up. And so these each of these cells is about 30 to 60 miles wide. And these troughs here they look flat, but they're about 330 feet deep. So these are pretty big. We found no craters down to 230 feet per pixel in each of these images. So that's pretty significant. The calculations are that this ice in some of these areas is less than 10 million years old, and no more than 10 to 30 million years old. And that whole area maybe got hit a billion years ago, but the formation of the ice keeps happening, or the bubbling up of the ice keeps happening. There's a heat source down below. Where that energy comes from exactly is unclear. And here's just some interesting close-ups of some of the edges of that big giant nitrogen glacier. Just imagine what this looks like up close. Pretty cool. Now, if you're wondering what scientists do, they love paint by number. Basically, what they've done is they've taken lots of different terrains and assigned colors to them. I'm not going over this entire drawing, don't worry. But just know that they've found lots and lots of different terrain features, that they've also mapped out where the bubbles are in this icy area right here. You can see them mapped out. Just looks really cool. We were not expecting any of this. We were not expecting anything like this. Pluto absolutely surprised us. Now, it was known that Pluto has a really thin atmosphere, and one of the reasons why they wanted to get New Horizons past Pluto when they did was they wanted to make sure that the mission happened before Pluto's atmosphere froze to the ground. You saw that orbit, that angled orbit. Well, it's a pretty elongated orbit too. Pluto takes 249 years to go around the sun once. And so at some point, it's even farther from the sun than it is now, which means when it gets out far enough, what little tiny bit of an atmosphere it has is going to freeze to the ground. And it looks as though that's already happening. Indications are very recently that the freeze out of the atmosphere has already begun. And so, but what we weren't expecting is, look at all of these hazy layers. You can see it looks like a layer cake. And the complexity, the number of layers, just really surprised everybody. And take a look, you can see some of the icy area, the glacier right here. You can see some of those icy mountains here. Let's take a close up. This is just one of my favorite pictures of the entire solar system. It just looks like a place. Here are those 11,000 foot tall ice mountains. And these are water ice. And these are water ice mountains floating on a nitrogen ice glacier. Water ice is less dense than nitrogen ice, and so it's going to float on top of the nitrogen ice. The steep mountains here show that this area is made of water ice. Different ices, nitrogen, methane, and carbon monoxide, are too weak to support such steep angles. So the only type of ice amongst those that can hold that shape is water ice. And so we see water ice peeking out in lots of different locations on the planet. Just a really interesting picture showing the ice to one side and the craters to the other side. And there's just a very pronounced difference in the texture between the younger areas to the east and the cratered areas to the west. Now take a look. You go, okay, ice mountains, few craters, cool. Take a look at this thing right here. If you're looking at this on a phone, see if you can enlarge in here, just so you can see it just a little bit better. It's a flat feature that's about 20 miles wide. It's a frozen lake of nitrogen. But how can a frozen lake exist? It means at one time, this lake may have been liquid nitrogen, but for that to happen, the temperature had to be warmer. The air pressure on Pluto needed to have been about 10,000 times higher than it is now. A possible answer is Pluto's tilt may change over time. And if its tilt changes about 20 degrees, that may result in this part of Pluto facing the sun a little more directly, increasing the temperature, increasing the air pressure, and that would allow liquid nitrogen to flow across the surface. Now, no, I'm not saying liquid water, or it's not that warm. Liquid nitrogen is still at a few hundred degrees below zero. It's still pretty darn cold. But at one point, we think this frozen lake of nitrogen used to be a liquid lake of nitrogen. And I mentioned flowing. Well, take a look at this feature right here. This may be a little remnant of a river, as in a possible liquid nitrogen river in the past. So not only do we have moving ice, we may have had liquid nitrogen rivers and liquid nitrogen lakes on the surface of Pluto. What a cool place. Sorry, pun not intended. Anyway, take a look at this stuff. This has been called bladed terrain. We have no idea how this forms. We don't see this anywhere else in the solar system. The terrain looks like lots of little blades all standing next to each other. Those ridges rise 1,000 feet above anything surrounding. So we have no idea what makes this. So I think we just need to go back to Pluto sometime. Anyway, here's some craters in other parts of Pluto. And you can see some of these craters. This is probably one of the youngest in the picture because you can still see some of the dark stuff that splashed out. So something from space smashed into here, and some of the dark stuff splashed outward and onto the lighter terrain. You can see there's different layers. Kind of looks like a lighter area in the bottom, a darker layer up above that, a lighter area above that, a darker area above that. So anyway, the layers usually mean some kind of change. Something happened, but at the moment we don't know why that terrain there is layered as it is. And this is Pluto also. When the spacecraft flew past, it turned back and took a photo of the entire planet, and the sun was almost directly behind Pluto. So it was a spacecraft on the other side, sun on the sun side, and it was shining through the hazy atmosphere. And you can see that Pluto's atmosphere glows blue. If you were standing out on the surface of Pluto, the sky would not look blue, it would look black. But you can tell the color of the haze is definitely blue. This is a true color picture of Pluto's haze. There were suggestions, just tiny suggestions, that there may be clouds, just a few in the atmosphere of Pluto. So just a suggestion of a few of these. I'm trying to highlight them just so you can pick them out a little bit more easily. But they're all very low lying. There's no broad storms or anything like that, like we've got here on Earth. We can't confirm that those really are clouds. They are suggestive of clouds. Again, just goes to show you we need to go back at some point and take another look. This is Pluto's moon, Karen. And immediately your eye either goes to this feature, this crack right across the middle, or this reddish splotch here at the North Pole. This crack right here is a canyon system that stretches for more than 1,000 miles across the entire face of Karen, and probably goes even farther over onto the other side. We only got a photo of one side of Karen, we couldn't get the whole thing, but it's 4 times as long as the Grand Canyon and twice as deep. And this canyon system indicates that something pretty titanic happened in the past. So more than likely, the interior of Karen may have held liquid water at some point. And of course, the water froze. Now I'm going to put this in perspective. There's some story that we all can relate to here in Northern Illinois. Let's pretend you have a fancy flower pot out in your backyard somewhere, or there's one in a park nearby, something like that. A fancy terracotta flower pot. Oops, someone forgot to bring the fancy terracotta flower pot in for the winter. It sat out there the whole winter. You go out there for the spring and you lift up your terracotta flower pot and it falls apart. Or you may have noticed that maybe there was a planter somewhere in a park that, oops, someone didn't get it in quickly enough before everything froze, and it fell apart. So what happened? You've got material inside the flower pot. Water gets inside the flower pot. It freezes. Ice takes up more space than liquid water, and so ice expands and it will break the flower pot. Why am I speaking so specifically of a terracotta flower pot? Because this is what happened to me a few years ago. It got really cold in November before we got the stuff in from our backyard. And oops, one of the large flower pots was left out all winter long, and it froze and thawed and froze and thawed and broke. So that's what happened here, that the water inside the moon froze, cracked the surface of the planet open. So it's a really fascinating thing to think about. And so this material is material that when it's exposed to ultraviolet light from the sun, it turns red. And so that is what you see at the North Pole of Karen. So just another close-up look at this canyon system. It kind of reminds us a lot of the Valles Marineris canyon system on Mars. So, but one thing you have to remember is this looks like it's a surface of rock, but the plains are flooded with ice. This is an icy surface. So it's fascinating because we see gray and you're going to think, oh, rocky surface. No, this is an icy surface. And one possibility for this smooth icy surface is a kind of cold volcano called a cryovolcano. And so the internal water ocean could have frozen a long time ago, and the moon cracked open, and that could allow water-based lava to reach the surface and spread out over the surface. So lava does not always mean melted rock. Lava can mean just a melted material that can then flow outward. So this is a surface maybe made pretty smooth by an ice volcano. So again, you're not looking at rock on this surface, you're looking at ice. So, and what kind of ice? Same stuff that's in your freezer. This is water ice. So this is a composite to show you the striking differences between Pluto and Karen. The color and the brightness of both of them have been processed identically. So where you see dark gray on Pluto, that is dark gray on Karen. That's a similar type of material. And so where you see the reddish stuff on Karen, it's very similar to the reddish stuff that's on Pluto as well. So these are false color images, but they've been processed identically. And so you can see the surfaces are quite different between the two. I mentioned the moons. So Karen is this part down here at the bottom, but then you have Styx, Nix, Kerberos, and Hydra, and they are teeny tiny moons. But take a look. Can you kind of tell that there may be a couple of pieces to at least a couple of these? Maybe this one here? Can you kind of tell sort of a suggestion that this might be a couple of pieces that are stuck together? These moons are as old as Pluto itself. The surface of Kerberos is about as black as a charcoal briquette. The others are about the color of sand. All of them have water ice on their surfaces. Karen is about the size of the state of Texas. and the others are in the 10-mile to a few tens of miles wide. So much bigger for Karen, much smaller for these others. And nothing like this has been seen among the rest of the planets. All 4 of these small moons are more reflective than Pluto. They spin really quickly, much faster than Pluto does. Here's a close-up image of Nix and Hydra. And Nix has a reddish spot. Still need to figure out exactly what that is. But the entire moon system of Pluto, this supports the idea that the moons, including Karen, formed early on in Pluto's history when something collided with Pluto and the material splashed out and formed the moons. Karen is less rocky and more icy, which is what you would expect from something that formed in a collision. Nix and Hydra here are covered in water ice. And after they counted the craters on the surfaces of these places, we see that all of them are about the same age, which points to a common origin for all of them. Likely something collided with Pluto in its distant past, which formed all of the moons, Karen included. Now, there's the whole debate as to what you call a planet and what you don't call a planet. Now, I'll get into that in just a sec, but I just wanted to point out some of the other objects that are out past Neptune, Pluto included. So you got Pluto. Pluto seems to be the largest of the what are called trans-Neptunian objects out past Pluto. And so Eris is almost the same size as Pluto. Haumea, I'll get to that one in a second. You're probably going, wait a minute, why does it look like an egg? I'll get it to you in a second. But we've got Makemake, Gonggong, Quaoar, Sedna, Orcus, Salacia, and this one, which doesn't have a name yet. They're all processed, all these drawings, these are not pictures, but all these drawings are processed to the correct color. So they're approximately what the color is that we actually see. Quite a few of them have moons, and Haumea, this one here, has a ring. It's got 2 moons. It is spinning so quickly, it's flattened itself into this egg shape. And so that is kind of an oddball, but there are quite a few things out past the orbit of Neptune. And even when we take a look at Eris, by the way, scientists get excited by squiggly lines on graphs. And so I will explain the squiggly lines on graphs. The bottom squiggle is the colors that we see reflecting off of Pluto. The top squiggle is the colors that we see reflecting off of Eris. Just notice the shapes of the squiggles. They're similar, right? You can see they dip down and rise up in the same general locations. So that tells us that Pluto and Eris are covered in similar stuff. It's just that Eris is brighter, and so it's a brighter. It reflects more light, and so you can see that they've represented that in the drawing here. So you can see without even knowing what the materials are. That doesn't matter. Just notice that the squiggles are similar. So if you're wondering why scientists get excited by squiggly lines, that's why, because they can tell us an awful lot about what the surface is like for a world that we have not been to yet. So if you want to start typing your questions in the chat, go right ahead. I'm going to do my best to explain the whole planet, Pluto as a planet, Pluto not a planet kind of thing. So Pluto prior to 2006 was called a planet, but prior to say the late 80s, early 90s, the 9 planets were all we knew. The planets and their moons and asteroids and comets and all that. But the 9 planets, the 9 classical planets, as we call them, are all we knew. And then we started finding stuff out past Pluto. And some of the stuff we found was very similar in size to Pluto. And so the scientists started talking to themselves like, what do we call this stuff? And then someone, I don't know who, probably just a general thought was, we don't have a definition for the word planet, do we? We probably need one. Okay, let's put it to a vote. So there was a group of scientists called the International Astronomical Union, and that is not made of all astronomers on the planet. Not every astronomer is part of the International Astronomical Union. And at their, they have a conference every 3 years, and at their conference in 2006, they put it to a vote. They put the vote on the last day of the conference. Lots of people had already left the conference. I'm not sure if they knew that that was going to be voted on at the end of that conference. And so they voted on the definition of the word planet. And the way it turned out was Pluto didn't meet all parts of the definition. So it wasn't like they were trying to demote Pluto, is they were trying to come up with a definition to try to explain bigger or the small rocky things close to the sun, the icier squishy things farther from the sun, and all that other stuff out past Neptune. They were trying to essentially say, okay, we've got these regions of things. So you had a bunch of astronomers who they're not planetary scientists, but they basically said, okay, how can we differentiate planet from not planet? First off, planet needs to be round. Okay, cool, round. It has to have enough stuff to pull itself into a round shape. Cool. Second part is planet orbits the sun. Makes sense. That means moons aren't planets. Third part says, and this is the part that's really confusing, and you're probably going to go, huh? Third part says that a planet needs to have enough mass and therefore enough gravity to clear out its orbit of other stuff. Okay, great. Except for one little problem. If you put Earth out where Pluto's orbit is, Earth would not be big enough, not have enough mass, and therefore enough gravity to clear out an orbit out there of other stuff. Earth would not be a planet if it were at the distance that Pluto is from the sun. So we have a little problem. We have one group of astronomers who says Pluto's not a planet. Then you have the planetary scientists going, can't we have more than one definition and everyone's okay with that? This happens in science a lot. Here's an example from astronomy. The word metal, M-E-T-A-L, metal, means different things to different people. Metals are certain elements with certain properties on the periodic table. That's one definition. Another definition of metal is, you're talking about stars. A metal is anything not hydrogen or helium. So you have the stellar astronomers saying, that's our definition of metal. You have the chemists going, well, this is our definition of metal, and everybody's cool with it. Everybody has their own different definition based on what they need. So what it boils down to is, if you want to call Pluto a planet, you can call Pluto a planet. The International Astronomical Union definition, it might not be a planet. But if you just say round orbits the sun, seems like that might be a pretty good definition to me. So you won't hurt my feelings if you call it a planet. So we got a few questions. So there's a comment about a UFO that Clyde Tombow saw. I can't speak to that. I don't know anything about it. So I'll have to go by what the comment is. I can't speak to whether or not it's true or whether he actually saw anything or what he actually saw. I don't know anything about that. I'm so sorry. Jane asks, will the James Webb telescope be in this area some years down the road? No. The James Webb Space Telescope is going to orbit the sun, but only about 1 million miles away from the Earth. So basically draw a line between the sun, the Earth, and go 1 million miles past the Earth. That's where the James Webb Space Telescope is going to orbit. the sun. And it will be able to study the planets. It's not going to go to them. So presumably Pluto, I would think, would be one of the targets. If it's not, it should be. So there we go. So even though Pluto's moons are about the same age, could some of them have been captured trans-Neptunian objects rather than debris from an impact? That was one of the ideas originally, but it seems as though because of their spin, because of their orbits, because of their composition, that says, and it would be the composition, I think, that would be the telltale. If something was just captured, it would likely be quite a bit different from whatever captured it. And so it is unlikely that these are captured objects, that these objects absolutely, almost definitely formed from a collision. So yeah. So is Pluto's classification a dwarf planet? According to the International Astronomical Union, yes, round and orbits the sun equals dwarf planet. The asteroid Ceres, it's an asteroid and it's a dwarf planet. It's round. Pluto, Eris, and several of the other objects I showed in that last picture, the last set of drawings. Several of those objects are dwarf planets as well. But again, that is according to a handful of International Astronomical Union scientists who voted at the end of a conference in 2006. But the definition of the word planet. Can you tell where my loyalties lie? I think it might be pretty obvious. So, all right. Any other questions before we sign off for tonight? Oh yes, I agree. I don't know if what the name of E is, but Pluto will always be my favorite planet. I agree. And honestly, it has become, if not my favorite, I'd say I'd put Mars and Pluto. Oh, Emily, hi Emily. I know who Emily is. So I would put them both there because Pluto just turned out to be so different from what we thought. You would have expected it to just be a dark, frozen, cratered, lifeless nothing. And yet we found parts of it are cratered, it's layered, it's bubbling ice, it's floating glaciers, it's icy mountains, it's some terrain that we have no idea what this stuff, what the stuff is caused by. It has moons that are interesting and strange, and they seem to be leftovers from a giant collision, and just there's way more than we could ever hope for. So I hope we get to go back there in the future. So any other questions? I know there's quite a few of you out there, so I'm thinking you're probably thinking you have to let all this sink in.
Hey, oh, look, go ahead. I was just gonna say, I have an announcement in case anybody is still with us and they want to know when the next time you will be with us, Michelle. We're gonna have you talk more about icy worlds. What a segue, right? We're gonna have you talk about more about icy worlds on January 31st, another Zoom program. So that's already on the calendar if you want to register.
Thank you for mentioning that. And Phyllis and Chip ask, how do the size and mass of Pluto and Earth compare? So Earth is about 8,000 miles in diameter. Pluto is about, I think it's about 1,200 miles in diameter. And the mass, you got me on that one, Phyllis and Chip. I need to look that up. So mass of Pluto, and this is what I love. I mean, I realize I would rather be with you guys in person, but we're keeping each other safe. But this is the cool thing that I can just look something up at a moment's notice. The mass of Pluto is 2/1000 that of Earth. So not much, not very massive. Mary says in a comment just sent to us, I have a round object like Pluto in my background. It's an exercise ball, Mary. So that's all that is. Do all planets rotate? Yes. Earth rotates in 24 hours, and Mars rotates in 24, let's see, Earth rotates in 23 hours, 56 minutes. Mars rotates in 24 hours, 37 minutes. Jupiter rotates in about a little under 10 hours. Saturn is slightly slower, I think. And that Venus orbits, or rotates, sorry, once every, oh, I get the number mixed up. I think it's about once every 240 something Earth days. So it orbit, or I keep doing that. It rotates very slowly, and it rotates the opposite direction. And I think Pluto is like that as well. I believe Pluto rotates in the opposite direction as well. And so let's get the rotation of Pluto. It is, let me see if I can find it real quick as you're all staring at me on a screen, watching the captions go by. It is, I'm trying to find it. Rotation. Oh, about once every 6 Earth days, but the other direction. So we rotate counterclockwise, looking down from the North Pole. Pluto rotates clockwise, looking down at the North Pole. So there you go. All right. Any other questions before we sign off?
I have one final question for you.
Yes.
So someone mentioned the James Webb telescope earlier, and I know I had asked you personally if you had any quick info on that. Could you just give us a quick summary of where they're at right now?
Yeah, for sure. So for those not familiar, the James Webb Space Telescope is the successor to the Hubble Space Telescope, not a replacement, but a successor. And it is a telescope that will observe completely in the infrared part of the spectrum. Hubble mainly observes light that your eyes can see. Infrared is a little more like, think of it like heat, that kind of a wavelength. Anyway, it is a bigger telescope. It's very complex. They've been designing it, building it for the, oh gosh, they've been working on the design since 25 years ago. It has been built, it has been tested, it has been packaged up, it has been put on a boat and sailed to French Guiana. The European Space Agency has their spaceport launch site there. Why there? It's very near the equator. And so anything launching closer to the equator gets an extra oomph from the Earth's rotation. And they're getting it ready for launch, and they needed to get another rocket off the launch pad a few weeks ago to clear it out of the way, and that went off without a hitch. So they're putting the rocket together now. They're getting the spacecraft ready to go. It is supposed to launch December 18th. Let me just double check. And I checked a few days ago. Space telescope launch, because I can't talk and type at the same time. Still set for December 18th. So fingers crossed. It is really complex. It is not a done deal that this thing gets off the ground. I mean, there are a whole lot of things that could go wrong. So we'll see how it goes. So then after we're reasonably assured that it will actually work, we'll schedule a talk on the James Webb Space Telescope. So I got one ready to go. I hope I'm not jinxing myself by doing that. I'll put it in the text, the James Webb Space Telescope. There you go. James Webb was the NASA administrator in the early 60s. He essentially got the Apollo program going. And so they decided to name the telescope after him. So.
All right, cool. Thanks so much. Yeah, we got another comment. Thank you. Interesting as always.
Thank you, George. Thank you. Thank you. I think George has come to some of my talks before, I think. So I think I recognize the name. So it's great to see your names. I wish I could see your faces, but we will be together when it's when it's, oh, that's right, George. And we will be together when it's safe. So stay safe, be well, everyone. Have a wonderful Thanksgiving, wonderful holiday season. We'll be together in a few months again to do another talk. Icy World's all about icy stuff, not just Pluto, but other things as well. So I look forward to that.
All right, we do too. Thanks again, Michelle. Take care.
Thanks, you too. Bye-bye.
All right, bye.